Hello all, and welcome to update number 8. Happy New Year, happy 2026 to everyone. So I didn't put out too many updates over the last week, but I have been doing a considerable amount of work on Zig Clr, including a major update that really enables some of the things that I'm going to be showing you. But I think maybe what I should start off with is a summary of what I've completed and a list of things that I'm planning to do. Hopefully this will take me about 2 or 3 more weeks into January, and then I'll call it. But I'm really excited because I think that the system that I've built has a lot of potential. So this is what I've built out. I've built out undefined value tracking, so you can tell whether or not something's undefined. Memory safety analysis, so that's use after free, double free. Null safety, so that is if you do a dangerous null unwrap, which is the dot question mark in Zig, will I be able to guarantee that will never cause a crash? Union variant safety, so that is if you do sort of the aggressive union field dereferencing. If you're not on the correct tag, then that's undefined behavior in Zig. In safe releases, it will panic, and if you're using an untagged union, it may do weird things. I have completed branch support, so that's both ifs and switches. I've done FieldParentPointer safety, which is kind of a unique to Zig, if you will, form of critical safety, and I'll show you the consequences of one of them. And what I've got planned are loops, so that's for loops, while loops, and maybe select loops, globals and thread locals, regions, so that's arrays and slices, which look a little bit different from how we handle just single variables, which is what I've been doing so far. Recursive types and recursive functions, I have kind of a general gist of how that can be done, and I'm hoping to also be able to do async await, which I think will require another sort of memory safety protection, which is to make sure that you can't mutably use a pointer in 2 different places. I think that this is possible in Zig without even having to tag your data types. And by which I mean is that you should be able to track whether or not a pointer has been used. And if it's used in 2 different branches or 2 or 3 different branches in an async await system, then it should come back and say, hey, you tried to use this in more than one spot. That's not allowed. I think that's kind of exciting that like you can do these sorts of analyses in Zig without tagging with ownership or anything complicated that Rust does. That's what I'm planning on doing, and I think at the very end I'll implement a tagging system which will allow you to coerce the compiler or the Zig Clr analysis system into letting you do something wrong. Okay, so what I do want to show you for today is this FieldParentPointer stuff. So let's look through this code, and then hopefully you can understand what's going on. So in the beginning, I'm going to define this struct here. It's got one member, and that member is a U8. We're just going to call that X. And in the main function, we're going to use an allocator. It actually doesn't matter what allocator we use. And then we're going to create a struct of S. We're going to call that myS. Then we're going to call this child function, which I very creatively called child call, and we're passing it a pointer to the X field. Then here, we're going to back out of the X field from the pointer that we got and retrieve the parent pointer, which is a S. So here we go. Const child S is an S. And then in our child call, we're going to go ahead and destroy child S. So we're going to delete the memory there. And then also in the main function, we're going to destroy myS. Well, myS is the same as child S, right? These are the same pointers. And so this should cause a double free error. Well, let's see what happens when we run it. And you can see it immediately says double free in FieldParentPointer.main. Line 15, so line 15 is here. This is where the double free occurred. Child S was previously free, and note that it'll tell you that the variable name of it was child S at the point where it was previously freed on line 9. So there we go. So that's line 9 right there. And it was originally allocated on line 13. So that's right here. So that's where the original allocation occurred. One other thing you might have noticed, oh, and by the way, field parent pointer analysis will correctly track all the field parent pointers for things like undefined safety, union safety, like all of the modes of checking different safety forms in Zig are completely orthogonal and also composable. So so as I build out more things, the nice thing is that they're completely independent of each other, but the heuristics of tracking what corresponds to what are exactly the same. So the way that I've designed the system seems to be pretty robust. And after doing a couple of pretty aggressive refactorings to make it more, I guess, sane, if you will, I think I'm in a good spot. This is actually really kind of what was a challenge because this sort of safety profile doesn't really exist in any other language besides Zig. This is a pretty unique sort of thing that you have to track. And it really did force me to do a fairly major refactor of how everything works in Zig Clr, and I'm pretty happy with it because I think now I'm on a really the right track, and I think even this track will give me the capability to do async await analysis and make sure that like we don't have aliasing problems. Last thing to note is that if you've noticed in the previous videos, all of the compilations and analysis have been really slow, on the order of several seconds, and in many of the videos I've had to speed it up. And if you notice in this video, it went instantly. And the reason why I'm able to do that is because I've now compiled my instrumented Zig compiler into release fast mode, and I've also compiled the library in release fast. I've worked out enough kinks in them that I know that they're pretty robust and are going to do the right thing. And so both of them are running extremely fast now, and now I'm running 130-ish integration tests every time. Takes about like a minute. Where previously the same number of tests probably would have taken somewhere around 10 to 12 minutes. So release fast mode, key to unlocking huge speed gains. I will probably have only a handful more updates, but like and subscribe, share this with anybody who doesn't believe that it's possible to do memory safety outside of Rust. It really is. Like I'm really confident that even if this specific software that I write is not capable of doing everything that we need, we could use the same sort of strategy, which is to analyze error and maybe compile it to, say, a theorem proving language or some sort of formal methods to prove that you have a safe system. All that is now within reach, and I'm really excited. If you want to support the work that I've done in the past, I will leave my Buy Me a Coffee link in the bottom. Thanks.